All right, so now I'd love to present Dr. Jim Misewich, who will give us an opening introduction.
Thank you very much, Jay, and let me also add my welcome to everybody. I see some old friends in the audience and some new faces. Thank you all very much for coming. I'm going to give you a very short overview of the energy research at Brookhaven. We are a Department of Energy Laboratory, so I wanted to just give you a brief overview of some of the things that we're doing in the energy area. And it would outline some areas for potential collaboration. These are certainly areas that we feel are interesting and important to the national interest. Because we're in the Northeast, I always like to start off with a look at the New York energy flows chart. Many of you have probably seen the DOE talks about the national energy flows chart. This is the New York version. And it sort of outlines some of the challenges that we have in New York State. And what you have on the left-hand side, you have all the sources of energy that New York uses, and as you go from left to right, it shows where it goes. So, for example, most of the petroleum is used for transportation. Most of the coal is going in for electric generation. But there are a couple of salient features about New York energy use I'd like to point out. Number one, even though New York has over 6% of the population, we only use 4% of the primary energy. In some ways, New Yorkers are the greenest state in the Union because our per capita energy use is a fraction of the, only 2/3 of the national average. Even more interesting, in terms of carbon dioxide, we're even better. And that's because the amount of coal that we use is proportionately very small. A lot of our electric actually comes from nuclear and hydro in New York State. So we happen to be a particularly green state. Of course, you have the same sort of issues as on the national flow chart. A lot of petroleum goes for transportation, and in terms of carbon dioxide reduction, you'd like to do something about that. And in fact, even though we're the greenest state of the Union, we have some substantial challenges in front of us. The governor signed an executive order that mandates an 80% carbon reduction by 2050. This is really hard, especially given that New York is already so green. There's very little low-hanging fruit. And whatever scenario you use to get to that goal, you're going to have to increase electrification, particularly in light vehicle transportation. And you're going to have to displace fossil fuels with sustainable fuels, fuels that are more sustainable, renewable fuels. And so this actually maps onto Brookhaven's energy research. Broadly speaking, we're looking at electric systems and we're looking at those sustainable fuels. And I would point out that the energy issues in New York really are reflecting the national challenges. So, with that said, this is a little summary of what we're doing at Brookhaven. We obviously have a collection of facilities. We're in the Nanoscience building, but we also have, if you look out the windows to the east side of the building, you'll see the new synchrotron light source, NSLS-2. It's a new billion-dollar facility that will allow us to do photon science down to the nanoscale. We're pretty excited about that facility. If you look out the west windows, here's the Nano Center over here. There's a brand new building going up, the Interdisciplinary Science Building. And we have some very specialized laboratories over there, including a suite of laboratories that have dry rooms for battery research and some very high precision laboratories for correlated electron physics research. We have way out on the east side of the campus, we have the largest solar farm east of the Mississippi. It's 200 acres of solar panels. And that produces 32 megawatts at its peak. But I always like to use this. It's 200 acres of solar panels. It's phenomenal. I actually should put up the satellite or the airplane photo. You get a better sense of the scale. But you have to keep in mind, I always like to use this as an example of the scale. New York peaks at 35,000 megawatts. So even though we've got 200 acres, that is just a small drop in the bucket compared to where New York is peaking. But it's needed. So there's the solar farm, and then we have supercomputing capabilities at Brookhaven that is state-funded and is also a user facility. We're very fortunate to be in the Northeast United States. We have a number of collaborators. Stony Brook University helps to run the laboratory. They're they're partners with Battelle. We have joint appointments with Columbia, with Cornell. We have connections with a number of industries in the Northeast and the university. It's a wonderful environment. We have a lot of partnerships there, and I'll illustrate a few of those in the next few slides. But in addition, in New York, we have some remarkable organizations. And not least is NYSERD, it's the New York State Energy Research and Development Authority, which does a lot to fund research and technology associated with energy in New York State. And we also have the New York State Smart Grid Consortium, which is a unique organization that has brought together all of the utilities, the New York independent system operators, the industries, IBM and General Electric, the National Lab and academia in New York to worry about electric grid issues. We also have the Battery and Energy Storage Technology Consortium and an Energy Policy Institute in New York. So New York is a really great place to have a national lab to work together to focus on these energy challenges in electric systems and sustainable fuels. And as a national lab, we try to align ourselves with the priority research directions that have been defined by the Department of Energy. And we're currently involved with 4 of the Energy Frontier Research Centers. So that's sort of a snapshot of how we do business here at Brookhaven. And I want to give you a little bit closer snapshot of what type of things that we're doing here. And with my short talk, I'm only going to give you an overview flavor. But in terms of the electric grid, a lot of our work is on the material issues that underlie the problems in generation of electricity, transmission of energy, and storage of electrical energy. And there's some examples here. We're working with Columbia on an Energy Research Center on photovoltaics. You might hear a little bit more about this from Emilio or others today. We're working with American Superconductor, Superpower, the University of Illinois, and Argonne National Laboratory in looking at transmission challenges, particularly with superconducting lines. And by the way, the driver here for superconducting transmission is not the low energy loss, it's the capacity, the ability to replace 10 copper cables with a single superconducting cable. That capacity is the big driver, especially in the dense Northeast, where it's going to be very hard to build any new right-of-way through places like Westchester County. And then finally, energy storage is also critically important. There are wonderful materials opportunities here. This is actually an X-ray of a General Electric battery called Durathon, which is being marketed now by General Electric. And at Brookhaven, using the National Synchrotron Light Source, we had hard X-rays that were able to probe these batteries in operando while they were charging and discharging. We go right through the steel cases, we go right through the thermal packages that these things are on, and we can map what's happening inside. General Electric actually was very generous in talking about how Brookhaven gave them the basic research foundation they needed and the confidence to build their plant in Schenectady. So that's a snapshot of some of the material issues that underlie the electric grid problems and how Brookhaven is contributing. I'll skip this one because of time. The other area is sustainable chemistry for fuels. We're at Brookhaven, of course, we need to be able to generate fuels in a way that's sustainable. And so that means things like activating carbon dioxide, it's essentially reducing carbon dioxide so that you can synthesize new fuels from that, using hydrogen as a fuel. And Brookhaven's done a lot of work on fuel cell electrocatalysis, actually a lot of work that has been enabled by the Nano Center involves the use of core shell nanocatalysts that make much, much more efficient electrocatalysts for fuel cells. We've just recruited Professor Jingwang Chen. He's a joint appointment with Columbia University, who is also the head of the Synchrotron Catalysis Consortium. And this highlights the strength that we have at Brookhaven in catalysis. It's the ability to use the photon science and the electron microscopy that we have here to understand these nanostructured catalysts. Again, there's a wide range of collaborators whom we're working with on these types of issues. I'll skip this. So, just to summarize, and as part of the welcome, we realize that in terms of energy, we can't do everything. but we're trying to focus on those areas where we have enough critical mass and we exploit our facilities to make an impactful contribution. And so we've been working on the materials issues that underlie the electric grid, generation, transmission, and storage, and on the ability to do chemical conversions in a sustainable way. And for us, that means catalysis and nanocatalysis. Obviously, we're strongly exploiting both the light source, and of great interest to us is the and wonderful recent expansion has been utilizing the facilities of the Nano Center. And you're going to see some wonderful examples today, but I'll just point out one right now. Actually, let me just go back for a second. The ability to image these core shell nanocatalysts is something that we do at the Nano Center, right here in this building. This is an image I'm pretty sure was taken with the Hitachi microscope that you'll probably see downstairs. Having that capability to not only image these nanoparticles, make sure that we are, because we're claiming to make these core shell particles, how do we know that we're making what we claim to be synthesizing? Well, it's the imaging and also the spectroscopy. We're able to determine the distinction between what's on the shell and what's in the core of these materials. The facilities at the Nano Center, this is just one example of how the facilities at the Nano Center have advanced our ability to do science in this particular area. So that's critically important. It's, you know, we've chosen these areas where we're focusing because of the leverage that we get from our facilities. As I mentioned, we want to be aligned with the DOE. We are responsible to contribute to their mission, so we're focusing on these energy grand challenges and priority research directions. And something I'm hoping that this snapshot gives you, we're very excited about the opportunity to work together, not just within the laboratory, but with our external partners. I've given an example with General Electric, with Superpower, with American Superconductor, certainly with Stony Brook University, with Columbia, with Cornell, with RPI. These are wonderful opportunities for us, and we are very, we feel that these challenges are sufficiently large scale that we need to pull together the best folks from many institutions to address these challenges. So with that, let me once again say welcome. I think you're going to have a very exciting day today. I'm actually going to stick around myself for a bit and certainly enjoy your time. Thank you very much.